Hello and welcome. Today, we are slithering deep into the world of reptiles. And let me tell you, this group of animals has some of the most specialized, most fascinating designs for survival on the entire planet.
So, let's start with a puzzle. Just imagine for a second, how would you get around, really navigate all kinds of terrain, from slippery rocks to loose sand, if you had no arms and no legs to help you out?
And while you're thinking about that, what if your main sense of smell didn't even come from your nose? What if you could, literally taste the air with your tongue to figure out what's around you?
Now, this isn't science fiction. These are very real, incredibly efficient solutions that we see in the animal kingdom. They're just a few examples of the amazing biological engineering in reptiles. All right, let's dive in with a creature that showcases so many of these incredible designs.
First up, the snake. It is a true masterclass in adaptation. And we're going to start with that fundamental problem. How in the world do you move when you don't have any limbs?
Well, it turns out snakes have not one, but four amazing ways to move. You've got the classic S shape, that's called lateral undulation, for moving fast. For being sneaky, they use rectilinear movement, kind of like an inchworm in a straight line. In tight spots, they use a concertina motion, bunching up and then stretching out. And on loose sand, they have this incredible sidewinding technique, lifting parts of their body to glide right over the surface. Each method is perfectly suited for a different situation, which is just incredible versatility.
Okay, so getting around is one thing, but that's only half the story, right? You still gotta find food. And as smart as their movement is, the tools a snake uses to find and eat its prey, well, that's on a whole other level.
Snakes have this amazing sense of smell, but it's not really about their nostrils. You know that forked tongue you see flicking in and out? It's actually grabbing scent particles out of the air. Then it pulls them back into its mouth to a special sensory tool called the Jacobson's organ. This thing analyzes everything and tells the brain exactly what it's smelling. It's an incredibly precise chemical detection system, just perfectly designed for tracking down a meal.
So once the snake finds its prey, you have to wonder, how does it eat something that's often way bigger than its own head? Well, the source material we're looking at today says this system was specially designed. And when you see how it works, you'll understand why. It really is a marvel of engineering.
It's this awesome three-step process. So first, unlike our jaws, the two halves of a snake's lower jaw aren't fused together. That lets them move each side independently, literally walking their mouth over their meal. But then, how do they breathe? Well, in a final brilliant twist, they can actually push their windpipe forward, like a little snorkel, past the food, so they can keep breathing the whole time. It's a complete system, just perfectly built for the job.
Okay, so we've just seen the ultimate offensive weapon in the snake's jaw. Now, let's flip the script and look at the ultimate in defense. We're talking about the reptile that carries its own fortress on its back, the turtle.
A turtle's shell isn't just some shield it lugs around. Nope, it's actually part of its skeleton. That top part, the carapace, is fused to the turtle's ribs and its backbone. The bottom part, the plastron, protects its belly. And the whole thing is covered in these tough keratin plates called scutes. We're talking about a nearly impenetrable suit of armor.
But wait a minute, this amazing defensive design creates a really interesting biological puzzle. If your ribs are fused to your shell and can't move, how do you expand your chest to breathe? It seems like it shouldn't work.
The solution is just as clever as the shell itself. Since they can't use their ribcage, turtles use a whole different set of muscles, even some connected to their legs, to literally pump their lungs, pulling air in and pushing it out. It's a completely unique breathing system, designed to solve the problem of living inside a fortress. So, we've seen these incredible designs for an animal's own survival. But what about the survival of the whole species? This brings us to one of the most astonishing things in the entire reptile world. For many of them, determining if their babies are male or female isn't just about genetics, it's about the temperature.
Get this, the temperature of the nest while the eggs are incubating is what actually dictates the outcome. For a lot of turtles, cooler nests will produce males and warmer nests will produce females. And just to show you how creative this system is, for crocodilians, it's the exact opposite. Cool nests give you females and warm nests give you males. Incredible, right?
To finish up, let's look at a couple of ancient survivors. These are reptiles that have been around for millions of years, and it's all thanks to some truly unique and amazing features.
First up, the big guys, crocodilians. Have you ever wondered how to tell a crocodile from an alligator? It's actually pretty easy once you know the trick. Crocs have a narrow, V-shaped snout,
and you can see their fourth bottom tooth sticking out when their mouth is shut. Alligators have a broad, U-shaped snout and a cleaner smile. All their bottom teeth are hidden.
And here's something that totally breaks the reptile stereotype of just laying eggs and leaving. Crocodilian moms are incredibly protective. They guard their nest like crazy, and after the babies hatch, they'll gently carry them in their massive jaws down to the water and keep watch over them.
Now let me introduce you to a really special creature, the tuatara from New Zealand. People call it a living fossil because its family line is so ancient. And that number you see on the screen, 60, that's just a hint at its impressive lifespan. The tuatara can live for more than 60 years.
But the tuatara's most mind-blowing feature has to be its third eye. Yes, you heard me right, a third eye. It's right on top of its head, and it's called a parietal eye. Now, it can't see images like our eyes do, but it has a lens and a retina. Scientists think it works as a light sensor, helping the tuatara keep track of how much sun it's getting. It's like a perfectly designed, built-in solar detector.
So from jaws that can unhinge to swallow the impossible, to shells that are also skeletons, and third eyes that sense the sun, the world of reptiles is just packed with these elegant, highly specialized designs for survival. It really makes you wonder, what other incredible solutions are out there just waiting for us to discover?